Hi, I'm Michael Lloyd, crew chief and driver for the New Zealand section of SLUGME 6. SLUGME 6 has been going for quite a few hours now. The boys in the central commentary position have put some hard yards in, and I hope everybody who's been watching this event has learned a few things along the way and having a good time. There's a few more hours to go, so hang in there and see who can make the rest of this 24 hours. You know, SLUGME 6 is based on the 24-hour of Le Mans. You know, the cars have now been on the track for, some 14 hours. They've gone through that difficult night section. The sun's come up and everyone's feeling probably much better than they were. But there's some teams who have made some gains overnight, and it's now a time that you need to consolidate on those gains, and not only consolidate but push through and take some advantages. That's a little bit like SolidWorks itself. You've been modelling for a few years. You've learned the essentials. You understand the modelling process. You've put in the hard yards. You put some hard hours in. But you also know that there are better ways to do things. There are better tools to use. And, sometimes SolidWorks doesn't make that all obvious. Certainly, that's my experience. It's how my modelling has evolved over the years. I use different tools I did when I first started, and I certainly model our products far different than I first started. That's how this slightly advanced SolidWorks modelling using surface tools with solid models presentation has really come about. It's a bit of my story on my process of how I've evolved my modelling. So we'll have a look at a few surfacing tools, how they interact and how they work with solid models, and we might even pick up a tip or trick along the way. So keep an eye out in the live chat. I'll be there. If you have questions, queries, what's going on, throw them up. If I can't answer them, there's plenty of smart people out in this live chat. I'm sure I'll be more than willing to assist us. So sit back, relax, enjoy yourself, and enjoy the presentation. See you on the other side. Thanks for joining me. As I mentioned in the introduction, we're going to take a look at a few surfacing tools which we can use with solid models. So let's jump straight into this. It's going to run like this. I'm going to spend about 10 seconds saying who I am, what I do. I'm going to have a little nod to the overachieving New Zealanders in the 24-hour of Le Mans, and then we'll jump straight into the presentation. So who am I? Well, I'm Michael Lloyd. As you can see, I've kind of been around SolidWorks for a little while now. I've been involved in user groups for a little while now, as well as being a SolidWorks professional. I also happen to represent the Pacific region on the SLUGME committee. If you like this presentation, you like what you see and hear, might be interested in a few other things that I've looked at in SolidWorks, a little hardware review, a few other bits and pieces. Have a look at michaelllord.me, and it will take you to this page, and you can see some of the things that I've done on SolidWorks. And this presentation will be up there in the next couple of days. So this is what I do. I work in product development and engineering for a company called Tracker. We're a manufacturer of motorhomes, what you call RVs, and along with some special purpose vehicles. Anyone who's been around SolidWorks since 2018 would recognise this image. It jumps up every 10th time that you open SolidWorks. We're also very fortunate to have a splash up on Visualize as well. So this is what I do. These are our current range of products, and we use SolidWorks exclusively in our design as well as our manufacture. We use a lot of OE bodies supplied by the manufacturers, the likes of Volkswagen and Mercedes-Benz and Fiat. And our products are fully designed and developed in SolidWorks before we even touch a vehicle. And this is how, I guess, this presentation has come about. It's really about how I've evolved and how I utilise some of these tools in what I do on a daily basis. But before I jump into the presentation, it would be hugely remiss of me, because I'm presenting in the New Zealand time slot, not to pay tribute to what I'd have to say the overachieving Kiwis of this world. It's a great nation and small population, and really they just overachieve in everything, in business and sport, and it would certainly be remiss of me not to mention them. I think most people would know the story of the 1966 Le Mans. It was in a film released a couple of years ago called Ford versus Ferrari. It was based on a book called Go Like Hell. What the film conveniently doesn't really mention is that the majority of the drivers, half of the drivers who were driving for Shelby America were New Zealanders. Both Bruce McLaren, who was a young F1 driver at the time, engineer, and I think anyone who knows the name McLaren knows of his success over the years and with a wonderful F1 team and his involvement in automotive engineering and vehicles. But driving with Bruce on that day was a young New Zealander, Chris Lamont. Chris was a 22-year-old, again a promising F1 driver. Probably they say the most unfortunate F1 driver not to win an event, but I do believe the 66 Le Mans, Chris was 22, which I think is still the youngest driver to ever win at Le Mans. The film Ford versus Ferrari focuses on the British driver Ken Miles, but what it fails to mention that there was a New Zealander called Denny Hulme who co-drove with Ken in that race. So the 66 was the start of a great era for Ford in the GT cars, but certainly they wouldn't have been able to do it without three very great New Zealanders. It took a little while after that, but to prove it was certainly no fluke, in 2015, Earl Bammer and Brendan Hartley repeated the 1-2 in Le Mans. To prove that was no fluke either, they teamed up together in 2017 to win Le Mans again, and just to show you the overachievers that they all are. 2020, last year, Brendan Hartley again once more won the 24-hour of Le Mans. Now that I've indulged myself and some passions, let's jump into this presentation. So we're going to run through a few tools. Two of my favourites being Offset Surface and Cutwork Surface. But we'll also look at a few other tools that you find on the surfacing toolbar and how they're used. Again, including some of my more favourites, Delete, both the whole face and also bodies. So, without further ado, let's jump into SolidWorks. So just before I jump into demonstrations and showing a few of the surfacing tools, I just want to have a little explanation about surfacing and solid models. For anyone who hasn't used surfacing at all, it's not something to be particularly frightened of. Matter of fact, it's very, very similar to solid modelling. So I will demonstrate that to show that there are not a lot of differences between it. So let me just start a part, create a sketch. Just going to make those equal for the sake of it, and we're going to dimension it because everybody should use fully defined sketches. I use 50 millimeters. I guess while I'm speaking to an international audience, I do speak both languages. I was raised on an imperial system before I jumped into the metric system. And SolidWorks does the same. It's not real fussed what we work in. We know we can set our settings down here, but if you are working between both, you can just throw in 2 inches and it will automatically do a conversion for you. You can even throw in 2.5 inches. Whoops, he says 2.5 inches. And again, you can see that it automatically does the conversion for you. Let me just extrude this from the center, if you do like symmetry. So we have a solid body, and we know it's a solid body because the feature map tree tells us it's a solid body. But I can make that into a surface body. I can simply delete a face, and we can see that we've let all the solidness out, and we now have a surface body. And again, the feature tree tells us it's a surface body. But we can take that back to a solid model really simply. I'm just going to do a simple planar surface. He says maybe selecting the correct face might help next time. Should never work backwards. Again, just create a simple planar surface. We now show 2 surface bodies, and if I select those surface bodies, knit them together, you may also notice, let me just show you that in a second, we can create a solid, and we go back to a solid body. So very simple, very easy to work between surfaces and solids. While I'm at it, you probably noticed that I don't run large tooltips. One, I'm working on a very non-CAD workstation. It's the HP Spectre. So I'm working without a net a little bit, so anything may happen, but I don't have a big screen, so I keep the as much area to work in as possible. But I do run small icons, but I do run tooltips. I find it really handy if I'm just not paying much attention. If I just go across, I can actually see what each of these are very, very simply. All right, so we talked about 2 of my favourite features, and they were surface offset and cut with surface. Surface offset, or offset surface. Very simply, anything can be offset. As long as it has a surface, it can be offset. So we can simply offset it one way. We can turn it around the other way. We can zero it and make it a duplicate of the surface we're working on. Let's just offset that 10 mil. It's tucked in the middle there, but we know it's there. We can see it there. And the simplest example of cut with surface is you select the surface. You don't have really too many options bar which direction you want to cut it. And that's cut with surface. That's a very simple example. But you don't always just have surfaces. You can actually use planes. So you can select a plane, you can cut with surface, and we can cut with a plane. So this is that surface body which we can just hide. So that's the simplest example of offset surface and cutwork surface. But let's have a little bit more of a real life scenario, and this is probably the main reason why I look for these tools, which I do on a daily basis with this type of product. So this is a good example, or a typical example of what I see a lot on a daily basis. A lot of imported bodies I get direct from the various vehicle builders, so Mercedes, Volkswagen, and Fiat. And this is typical of a cabinet I might be putting into a vehicle. And you can see clearly that this cabinet is protruding through the bodywork, and I want to actually profile that or scribe that to the body of the vehicle. And I do that using the offset surface and the Cutwork Surface. So I simply start by editing the part. The offset surface tool, and I like to make it 3mm because we just want a little bit of clearance. We want a nice smooth line around it. And then I simply go ahead and I select these surfaces. There's a few tricky little ones in there we've got to be careful of, but it is just a case of selecting the surfaces that I want. This has a bit of a, I'll just grab that. This is a bit of a two linings, which we'll have a little example and make use of that. Let's just tidy up these top ones as well. And looks like I've grabbed them all. So let's just open up this part, and we can see we've got this surface, but we can't use it at the moment because obviously there's all these holes and patches, and we know if we try to do a Cutwork surface now, it simply won't do it because it's one knot extra into the bodies, and actually there's two surface bodies here at the moment as well because we have this join knot through here. So let's start with that. Let's use the delete face because I don't want that radius there at the moment. So let's delete that face. Let's use a tool called Extend Surface. And we've got 20mm on it, so that looks like it'll be fine. We're just going to select that edge. Just hit enter to recall that that command. I'm going to select this edge and this edge. Let's just get rid of this this part. So I'm just using Tab and Shift Tab, and I don't even have to find the part. If I just hold Shift Tab down, I can go over the top and it'll eventually find it. So Tab to hide. Right. I'm going to use the trim tool now, and we're going to use mutual trim. And the advantage of using mutual trim, it allows us to trim with both surfaces at the same time. But it also has a big bonus, and that is when you use mutual trim, especially on something simple like this, we might just have to talk among ourselves for a little while this machine catches up. Surfacing does tax your machine a little bit more, especially when you've got these imported parts. But the one advantage of that is when you do a mutual trim is that it does knit the bodies automatically for you. So we now end up with one surface body. So let me just throw a fillet in there now. And we'll just fillet that to, let me just move myself a little bit. 5mm. Whoops. And we'll grab that edge. And we'll fill that edge. Now we need to patch these bodies, patch these holes. If I select an edge and hit delete, it brings up, I guess, what I would call a hidden option. It used to be a hidden option. It brings up the delete hole feature. In 2018, SolidWorks actually introduced the delete hole icon. But anyone who's been using the software for any time, and I think even if you don't, once you've been using it, it's much simpler just to be able to select the edge and just keep going with it. So let me just just having a little think here for the moment. Oh, here we go. It's catching up with me. Never worked live with SolidWorks. There we go. No, it's having a little thing. It'll catch there eventually. Or not. Damn. Oh, here we go. All right, we're back up to date. So one of the things I find that with the delete hole, I've selected the edge and sometimes you don't get the automatic preview with it, even though I've got the edge selected. If you've been around the tool long enough, you realise that it's selected the edge. It mightn't give you a preview, but when I selected, when it catches up, it will actually fill all these holes for me in one go. Here we go. All right, let's bring that body back. Okay, we also need just to do this one here. And again, now we've got a complete surface right through the area where we need it. And now we can simply use the Cutwork Surface. We trim the surface, and you can see now it's described it perfectly where I want it. Now, I can just hide this body, but I find that once I've used them, I like to get rid of them. And if I select and hit delete key, it brings up the delete body. If you are looking for the delete body command, it's actually hiding over on the direct edit. Also too, just while we're speaking of things like that, surfacing was originally used as a reference tool more than a full modelling tool. So again, even things like Cutwork Surface, when you think, okay, let's if it's not on your surfacing toolbar, you thought, let's go and, oops, I don't want that. Let's go and add this to the surfacing toolbar. If you go to commands and you look in surfaces, you think, okay, where is the Cutwork Surface icon? Well, you won't find it in surfacing tools at all. You'll actually find it in features, and you'll find it hiding among the features. And he says, hiding up in this top corner. So it's actually a feature, not a surface tool, even though you'll find it hiding up on the surface toolbar. So now that I have that set, you can see that we've got an angle, and for me, normally I would then just finish that up because we're going to cut this on a CNC one day. So we're just going to select that, select tangencies, just do an offset and a bit of a drag for those, and then I would normally then just do a cut with through all. And now that I've got a nice clean edge on that panel, we just go back and look in the assembly. We've now got exactly what we're looking for, a perfectly trimmed edge or surface to the surface of the body. All right, let's jump out of that. So let's have a look at a couple of other tools. All right, so a not so practical example, but I guess, excuse me. So if we want to make this symmetrical, again, we go back and we look at the a more practical example of the Cutwork Surface, again, showing that you can use a plane, and we can cut the surface, and then we can go back and do a normal mirror. What happened there? Let's try that again. Oh, because I was trying to do a feature. We actually want to mirror a body. So again, we can make a part easy symmetrical, but that's not what I wanted to show. The delete face has a couple of options, and one of those is delete and patch. So by select these faces, we do have this extra bar, but I always find I do something silly like that, so I tend not to use it. So let's just grab those again. And with all those faces grabbed and the delete and patch, it now will delete those faces, patch it, and rename it as a solid body. So a very handy tool for fixing some of these parts which you may not want or be able to use in some of these more complex shapes. Another example of delete and patch is this part. You probably notice that it shows it as a stock part. This probably started its life as a part of a multi-bodied sheet metal part. Somewhere along the line, it got inserted into a new part. It would have had its references deleted, and now it basically isn't much more than a non-solid. But we can, whoops, let's just move this out of the way. If we measure it, we can see it. We see it as 3 mil. Let's just pull that down. But we see that the radius is actually 5 mil. Now, I'm no sheet metal expert, but as a rule of thumb, you would normally have your radius, your internal radiuses of a sheet metal part equal to the thickness of your sheet metal. That's not always the case. Some of that will come down to your brake press tools and your operators, but as a rule of thumb, we normally work on the same radius. So before I can convert that to a useful sheet metal part, I can use the delete face and patch, and I can select these faces. I'm using the D key, by the way, which if anyone wants to know how to bring that cursor up. And I can, again, use the delete and patch, finish that off. And now that we have those radiuses removed, it's now a simple part. If we want to do this, complete this as a sheet metal part, we can convert it to sheet metal. We have it set for a 3 mil thickness, a 3 mil radius, a fixed part, and because there's no bends to collect, it tells you there's no pre-made bends. We've just got to select the edges. And that one. And now we have a simple sheet metal part. So again, the delete and patch, delete with patch is a handy tool. And again, the same. We can actually use it if we want to get rid of these holes. We can select, go to the use surfacing toolbar, delete with patch, and again, you can easily then delete those surfaces, those areas. So there is another feature of the delete and on the delete face, and that is called delete and fill. Again, this is a this is a fiberglass component that we made. It's a face of a drawer. It, again, has been used as an insert part somewhere along the line, and again, the same thing somewhere along the line. It's been changed. We would have cut it, and then we've mirrored it, and we end up with this line. And while it's not a huge tragedy, I guess we could just display it as tangent edges not shown. We can simply fix this face pretty easily by, again, selecting the faces, using the delete face tool, but this time using delete and fill. So now we can create this nice smooth face just using the delete and fill. So again, we can work our way along into the same process along those edges, along that radius as well. That's interesting. So again, there is the option of tangent fill, which I probably should have had the preview up. So again, now that we have a tangent fill, you can see we have a much smoother edge. And again, we can continue working on all these faces. And I think probably the opposite will happen now. That's showing a strange preview. By getting rid of the tangent fill, again, we now have a smooth face. So it's a simple process of working your way around. So it's the three different functions of the delete face. All right, let's have another look at a couple of interesting ones using the delete face and fill function. That part. So this is typical of the things that I put up with on a daily basis. This is a body panel from one of the vehicle manufacturers. It probably started its life as a CATIA part or an NX part. It's probably been exported out to as a step file or an IGES file, and I've managed to bring it back into SolidWorks, and surprisingly we get a few errors and a few issues. This one's interesting that it shows a solid body and it looks pretty reasonable, but you can see that there is there's an unhealed edge. It's highlighted by in surfacing. You can set an options. And he says, thinking about display. There is a tick here. It says, show open edges of surfaces in different colors, which is what we have selected. And I actually always change that to a pretty bright color. It's set as blue as standard, but I like to change them to a slightly brighter color so they stand out a little bit more. So interesting, it's showing it on both surfaces. But a few tricks I've picked up over the years out of desperation to take some of these parts from surface parts to solid parts is that I can use the delete face and fill. I can select that and I can see by the preview that it looks pretty good. And by deleting that face, and again, you may just have to talk among ourselves for just a second or two here. It does tend to have to think a little bit here. Okay, not only has it filled that face, it's also fixed the other side, and it's made it a solid body. I'd like to be able to tell you why, but I can't. So we just accept that sometimes it does things out of mystery, but it does work. Another example of that, another sample of that. Again, this is a similar thing. This is a door pocket. Just get rid of real view there for a moment. This is a
door pocket which sits on the side of a seat panel. It comes in as again, it's a part. It's come in as a surface body, and no matter what I do and look on this, even using import diagnostic, I can't find an error, I can't find a gap, I can't find a missing surface. There's a few, if you look carefully, there's a few weird things go on in some of these parts, but nothing which would suggest that there's a reason that it's lost its solidness. But again, if I use the delete face and tangent fill, I just randomly select a small face. I normally just pick a little face. I look at it, and again we let it think for a second or two, and again it's simply replaced a surface, but it's also made it a solid body. And again, I can't explain it. Maybe someone in the chat, someone way smarter than I, may be able to give a good reason, but I tend not to think about it too much and just accept it as a success story. All right, I've got a little extra time. Let's just do one more thing, which is a little bit more of a, I guess a surfacing model more than a solid, but we'll make it into a solid eventually. But again, it will again show the offset surface and a few other surfacing tools. Again, we sometimes have to make, or sometimes we quite often have to make side panels. And you can see this is actually set up for a side panel, but we don't have those. So normally with that, I will I'll create a new part. Just quickly save that in here. And I'll simply insert that part and I'll just let it jump into space. So if I edit this part and I now go to the offset surface, make this a zero surface, and we can select that surface, this surface, this surface, this surface, and this surface. So if we jump back to the lining, do a little rebuild because it sometimes doesn't like that. We can now do what we did before in some of these things. Actually, oh, you know, we'll do that. Hit delete the whole. Let's just edit. Let's just select a few, all these holes. I have to pick one with way too many holes for this demonstration. Just a couple more. All in one hit. This one, this one, this one. Oh, this is a tricky one. And this one, oops, let's just edit those. Now we know which ones we've missed, that one, and that one. All right. Oops, we should pick these as well. Let's just start these ones as a separate feature. Don't want to push my luck too far. All right, now let's try and do these ones, but I doubt whether they'll do it because they're actually on a curved surface. This actually has a fold in this body panel, which makes things a little bit tricky. But there is another tool we can use to patch a few things, and it's called Untrim Surface. You can use the Untrim Surface in a couple of areas. Again, if you have a surface panel and you've got to fix, say, like this corner, you can do an untrim for that corner, so you can make a square edge if you want to get rid of again, a curve. But let's have a look what it does on this area here. Again, if we select where we want to go up to, again, you can see some of these, they come up a little differently. Don't always have to select all the edges. Oops, I don't want the face. I don't have to select them all. I do tend to, just in case that they don't grab all the edges, and I'm pretty confident I can get away with just doing that. And again, I can bring up this side the same. Again, sometimes there's a different amount that you have to select. Again, that one looks pretty good. And so I'm just going to do a little, again, let's just not push our luck. We're just going to delete those two faces. And I'm just going to do a simple, he says looking for the tool, boundary surface. So we can just select. There's always a little careful with some of these as well, because again, I need to actually use the selection manager to make sure I get all these parts. Sometimes they're a little bit, you can't trust. So we've got two there. I should really use the heal tool. I could have healed those edges, but that's more of a surfacing presentation for somebody way smarter than I am to do. So let's just select those. Oops, didn't quite want to do that. I was going to do a guideline, but I think it's followed it anyway. So let's just get these two bodies together. And while we're playing with things, we want this to be a much neater edge. We can go back and we can use the delete and fill. Just so we've got a nice smooth face. So again, a handy use of there. And if we just then use another tool called Thicken, let's just make that 4 mil. And again, by using the Thicken tool, it creates a surface body, a solid body. So let's just jump back in, and we now have that side lining in place. So again, you can see there is a range of tools that you can use and expand how you work in with solid bodies. As I say, they're not always obvious, and they hide them and put them on a thing called the surfacing toolbar just to fool you. That's kind of it. I hope you enjoyed that. I hope I managed to show you something different. I hope I showed you some different ways of doing some modelling techniques. As I say, if you like this presentation, it will be up on my blog post in a little bit after this event. Thanks for joining me. I hope you enjoyed this presentation, but more importantly, I hope I managed to show you something new, something that you can use, something that you found helpful, something which will help your modelling on a day-to-day basis. If you have found this enjoyable and helpful, and you want to do this a little bit more regularly, then jump over to SLUGME.org, see what other meetings might be coming up in your area. If not meetings in your area, well, consider about forming a group and becoming a leader. There are plenty of people who will help you out, and you'll certainly never regret it. Thanks for being part of SLUGME 6. And now, back to the gentleman in the central commentary position.